All right, welcome back, and we're continuing to work through our different ratio and proportion questions. So we have Tierney goes to the movie theaters and has $20 to spend on treats, and there is the prices. She buys 2 soft drinks, a chocolate bar of popcorn, and pays 13% tax. How much should Tierney receive from her $20? So this is a question you'll see on EQAO. Seems simple enough, but it has a couple of concepts in there that we need to focus on. So first of all, we need to know sales price. All right, we need to know how much was spent. So she bought 2 soft drinks, so that would be $2.29 plus $2.29. And then what did she buy? Chocolate bar and a popcorn, so one of each, 1.69, 3.49. So that means how much did she spend? Well, let's just calculate that out quickly here. 1.69, 3.49. So I got they spent $9.76. All right. Stage 2 or step 2 is tax. So 13% tax. So again, I'm going to use the ratio method. 113%. So oops, not over 110, over 100. All right, 100% of the price was 9.76. I want to know what the final price is after taxes. So I'm going to put that 113% in using our standard algebra method here. 113, 9.76 equals 100A. And this would be a short answer question on EQAO because there's 3 steps here. So first step was to find the cost, which I'm hoping everyone's able to do. The second step is taxes. So that's definitely part of the grade 9 curriculum. And then the final step, so A equals $11.03. The last part that sometimes people forget is we got to find the change. Because the question, if you look back up at the question here, it said how much change should she expect? So she gives a 20 plus 11.03 after taxes, and we get $8.97. So she can expect $8.97. All right. So that is your money question. And again, anything there, any of the steps that don't make sense, okay, stop the video and ask the teacher for assistance. So the next question here. 4-liter can of paint covers an area of 36 meters squared. What area will 10 liters of paint cover? So this is a straight up proportion question. This is one particular scenario. So we know that if we have 4 liters, it covers 36 meters squared. What happens then if we have 10 liters? What area can be covered? So this one, probably one of the easier ones in the last couple of examples, but there we are right there. We have to make sure if we have liters on top, liters has to be on top over here. The setup lets us know exactly what numbers get multiplied together. I'm going to drop the units. So I'm just going to go 4A equals 10 times 36. I'm going to divide both sides by 4 because we're trying to get the A by itself. Move this down a little bit. So A equals, and now it tells us exactly what we are multiplying together. So we end up with 90 meters squared. So therefore, 10 liters will cover 90 meters squared. All right, another one down. So we're looking at a variety. Like I said, these are all from EQAO. So it's giving you a feel of what to expect. So David and Shanice each take a 450-kilometer trip. David drives a car and uses 7 liters of gas per 100. Shanice drives a truck which uses 12 liters of gas per 100. Gas is 90 cents. How much more will it cost Shanice than David to drive 450? So yeah, this is definitely short answer question. Lots going on here. All right, so first of all, we need to figure out gas. So that's going to be step one, gas. And it's even more complicated because we got to do each individual. So we're going to do gas, and we'll do David, and we'll do, I'm just going to go SH, Shanice at the same time. So David's ratio, for every 7 liters, he can travel 100 kilometers. We know he's going 450. So again, see how the units have to match up. So we have kilometers, kilometers. So there's David's setup. So I'll call that the letter A. Cross multiply. So we have 7 times 450 equals 100A. Divide both sides by 100. So we know that. This is gas. This is how much gas he's going to use. Divided by 100. He's going to use 31.5 liters. So David's using 31.5 liters. Now, Shanice has her big decked out truck here, and it's using 12 liters per 100. We want to know, I'm going to use a different variable. I'm going to call it B. In that same distance, how much is she going to use? So again, we got kilometers both on the bottom. Now we can solve, and our method always tells us what numbers get multiplied and divided. So 100B, and divide both sides by 100. That will get B by itself. So Shanice, how much is she using here? Doing out the calculations, we have 54 liters. So she's using 54 liters. All right, so if gas costs 90 cents a liter, how much more will it cost Shanice than David to drive 450? So this is what I'm going to do for the second part here. So for part 2, cost. All right, well, I know the liter differential. Let's do that right away. Okay, so if we do liter differential, 54 minus 31.5, we know that 31.5, 22.5 liters. So therefore, Shanice used, why do they use such long names? Oh my gosh, 22.5 liters more. Now, how much does each liter cost? Costs 90 cents. So costs 0.9 cents for every 1 liter. We want to know the cost. So let's call it a C for 22.5 liters. Cross multiplying. Nice thing with this, 1 times C is just C. 22.5 times 0.9 is $20. So she's going to spend $20.25 more. Therefore, she spends $20.25 more. Okay, not the only way to do it. You could have done it, excuse me, could have found the cost of each person and then figured out the difference in money, but it just seemed to make it a little bit simpler finding the difference in the liters. So there's that next question taken care of. So again, this is a short answer question. So there's lots of steps involved there. That's why we're giving you some practice early on. All right, a mattress company has 7,000 mattresses to sell. The company claims that if the mattresses are stacked on top of each other, the stack will be 3 times the height of the CN Tower. The height of the CN Tower is 553 meters. Each mattress is 9 inches high, so we're mixing units. Aren't they nice people? We have meters, we have inches. Is the company's claim true? So they give us a scale here. Let's get rid of this 9-inch thing. So we know that 1 inch is 2.5 centimeters. Now we got 9 inches. So we want to know how many centimeters that is. So we'll call that A. We do our cross multiplication here. The nice thing with this, 1 times A. So it's just A equals 9 inches. 9 times the 2.5. So 22.5 centimeters. Let's convert that to meters. So 22.5 centimeters would be 0.225 meters. All right. Still 7,000 mattresses. So that's part one. That's actually the ratio and proportion part of this question, is to get inches into the meters. Part two, the height. Well, we have, what do we have? We have 7,000 mattresses, and each one is 0.225. So if we stack them all up, 7,000 times 0.225, we get 1,575 meters. The CN tower right here, CN tower, they said it's 3 times taller, so right here, 3 times the height, 3 times 553, 3 times 553 is 1659. So guess what? They are short. They're close. I would still, the question says, is the company's claim true? No, it's not true, but it's pretty darn close. So the answer then, no. They are, how far apart are they? 1659 minus 1575. They're 84 meters short. I guess that's quite a bit. All right, but they have a lot of mattresses, that's for sure. All right, the next example. Again, if you have any questions, stop it, ask the teacher. Clarence works at a vet's office. He needs to give a dose of medicine to a 24-kilogram dog. The dosage says that 10 kilograms gets 25 mils. Determine the dose Clarence should give the 24-kilogram dog. Well, we know that that's the given ratio. For every 10 kilograms, we should be giving out 25 milliliters of medicine. Now the dog, I have kilograms on top, so the dog is 24 kilograms, and we are looking for our milliliters, so call that an A. Now we're into cruise control. We've done this so often, everyone should be comfortable with this. 10A equals 24 times 25. Divide both sides by 10. A will equal, so plug that in, 24 times 25 divided by 10. So we're looking at 60 milliliters. So therefore, he should give the dog 60 milliliters. All right. So I think I have one more short video to finish this up, and we can move on from there. So you're getting a variety, again, showing you the different types of questions you can expect on EQAO and different ways to use a ratio and proportion. We'll see you in the next video.